So looking at evens for 4.1, our first lesson, in 24 and 26, you're supposed to find the zeros. 28, another zero. And then these, you had to look at it and say what degree it is, the leading coefficient. And I always write mine this way. If you want to switch it and write it like the book does, it doesn't matter to me. But I think of a graph, and I think of this side as being x goes to infinity and what happens with y. And then I think of this side as x goes to negative infinity and what that does to y. And so I write this every time, and then I just fill in this other part. It makes it easier for me. So 38, same kind of function, but 40 is a fifth degree with a negative coefficient, so it flips over and does something like this, which gives me down on this side and up on this side. 42, they said to sketch. So this was, can you remember, what can you remember from last year? So in 42, we're looking at these three zeros, and if you make each of them equal to 0, you can solve and say opposite math. This one's 3, this one's -2, and this one is -4. And then when you sketch it, you can just find those values on the x-axis because they really represent like 3, 0 as a point, and -2, 0, and -4, 0. So I have those three zeros because they gave me three factors. I also know that if I multiply x times x times x, it'll be x cubed, which means I have this in behavior, which means I can say that this side goes up and this side goes down, and then I connect my dots and make the loopy loops. So this is the sketch of it. I don't know how low this goes or how high this goes. I would need more information, like plug in some other points to get that. But this at least tells me, hey, if I wanted to make 0 in my chart, that would be easy to figure out. Like I could plug in 0 here, here, and here, and multiply it out and figure out what value I'd have. But as far as a sketch, this is a beginning sketch, and that's what I was looking for 42. So besides these that I haven't really talked about much, are there questions like the factoring ones 24 through 28? Any of those? Nope. Set it equal to 0 and solve. Jack good? Isabel good? All right. You at home? You good? Just kidding. But email me if you have questions. Okay, so let's see what's next. So we're going to add to the lesson and talk about zeros and multiplicity. And what happens with multiplicity is that if we looked at a problem, even like the one we just did, so the one we just did was 42. I'm going to rewrite it just as an example. And I'm going to compare it to if I had this multiplicity, which I haven't defined yet, but I will in just a sec. So if I rewrite 42, I've got x minus 3 and x plus 2 and x plus 4. So the idea of multiplicity is that 1 0, or more than 1 0, but a 0 is repeated. So multiplicity means that maybe x plus 4, we have another one. So we have a repeated 0. And what it looks like, normally we don't write it twice, but I wanted you to see it written out because that's important. Normally you would see it like this, and then you'd say x plus 4 squared. So you would see the multiplicity because it would have an exponent. And it can have any exponent, so it could be 2 or 3 or 4. It can't be a negative number or anything like that because that would mean it's not a polynomial anymore. But we have rules for what happens when we square things and how that would change the shape of our polynomial. So it started off being like 42, but I've changed it. So now tell me about this new examples in behavior. What's the degree of this new function? I don't really want to multiply it out, but I could guess at the degree. What would that be? So if I multiply x times x times x times x, how many x's is that? So 1, 2, 3, 4, because this one has 2 of them. So there's 4. Degree 4. It was originally a 3, and we added one more thing, so we made it a 4. So that changes the end behavior. So now the end behavior, if it's a degree 4, is the same. It will have end behavior that's both up, because there's no like big negative in the front. So what happens in the middle since I've changed that? So that's the thing that happens with multiplicity is you go and evaluate the zeros differently. I still have a 0 at positive 3. So this one's 3. This one's negative 2. And this one is negative 4. But something special happens at negative 4. It bounces. Because when you think about it, every time you have a number and you square it, it changes the sign. Like it's potentially changing the sign. So any number squared is always positive. So it ends up that we have the same sort of behavior happening at that value. And here's what I mean. If this is my end behavior, that means at the two ends, this time I'm going up. So in order for that to work, one of these zeros has to bounce, because I'm going to go at x equals 3, I'm going to go through, and at negative 2, I'm going to go through, and the only way for me to come out on this side is to approach this one, negative 4, and then come back up. So it bounces whenever you have an even exponent. And the word for that is multiplicity. So if you compare that to my other graph, where it went down, all of these have multiplicity of 1. And so it goes through. All the 1s go through. And this one goes through. I know that's not how you spell through, but it fits better in my graph. If it has an odd multiplicity, it will go through. So that's what's different between, even though we have the same exact zeros, my example of new stuff with multiplicity had a different degree, and so different end behavior. And if we actually plugged in a whole bunch of numbers, we would see how this works. So let's look at this one other way so you can see what I'm talking about. I'm going to do what's called a sign chart. And if you are ever in the building and in the pack or in 626, I've got some sign charts posted, and I'm going to explain those to you here so you could use them. It will help you with your graphs. And we may have some exercises on Delta Math that uses that as well. So I want you to have an idea of what I mean. So I have 1, 2, 3, 4 factors. I'm going to list them like this, though, with this one squared. I'm going to list them funny. It's going to look like a vertical list. X minus 3, x plus 2, and x plus 4 squared. And on the bottom, I'm going to write the zeros that I found. So I'm going to put them in order. Negative 4 is the first one on the number line, then negative 2, and then 3. And I'm going to check the signs that happen. I'm going to check where my graph is. So this is called a sign chart. It's going to tell me whether my graph is above the x-axis, above the x-axis or below. So above the x-axis would be positive values, and below would be negative values. So what we're going to do is we're going to pretend like we've got a pretend line here, like I've done when we did piecewise functions. And I'm going to consider numbers on this side and numbers in this column, between 2 and 3 in this column, and after 3. I'm going to consider what happens with all of my values. It may take me doing this 1 or 2 times for you to follow what I'm doing. But stop me and ask me questions if you have them. So here's what I'm going to do. I'm going to pick a value like, what if I pick -5? That is on the left of -4. I could pick anything. I could pick -6 or -10 or -100. I could pick anything on this side of -4. So if I pick -5 and I'm writing that there so you know what I'm doing in my head, I'm going to plug it in to every x value, and I'm just looking for the sign. I'm just looking to see if it's positive or negative. So if I plug in -5 into this first one, I would have -5 minus 3. Is that a positive or a negative number? It's going to be -8, right? So I'm just going to write negative here. Because if I'd have picked a different number, I would have gotten a different answer, but it still would have been negative. So it's only the sign. Can you see this value? Negative. I'm going to do -5 everywhere. So -5 plus 2, is that positive or negative? It's still negative. How about -5 in here? -5 plus 4 squared. Right? So it's squared. So what happens when you square anything? It's going to be positive. So actually it doesn't matter what I do here because anything squared will be positive. So I already know that if I plug in anything, I'm going to get a positive. The squareds make it easy because squared things are positive. So that part's done. So what I'm suggesting to you is, with the sign chart, if you were to multiply these 3 things together, you would be multiplying a negative number and a negative number and a positive number. What happens when you multiply 2 negatives and a positive? What value do you get? Positive or negative? Positive. So, does my graph look positive over here? Is it above the x-axis? Remember how I wrote above the x-axis? So it is above the x-axis here, and they match. Okay? So the sign chart also confirms what we're talking about with the multiplicity and the end behavior. This is a mathematical way to show that. So in this next section, should have drawn all my little dotted lines. Is this part of the graph above the x-axis or below the x-axis? This little bit, is it above or below? Here's x. Higher or lower? It's not a trick question. Is this above or below the x-axis? It's above. So I should get a positive value for this one too. Let's see. Pick me a number between -4 and 2. Oh, it's supposed to be -2. This is -2. My bad. So it has to be -3, right? That's the easiest one to plug in. So what I'm going to choose is -3. So all of these points are supposed to match. -4, -2, and 3. They're supposed to match my graph. This one it just looked like I randomly put in, but I fixed it. Okay. So now I'm going to plug in -3. -3 minus 3 is -6. I don't care that it's -6. I just care that it's negative. -3 plus 2 is -1, which is negative. And if I multiply those 3 things together, I also get a positive. Negative times negative makes positive times positive is positive. Look, my graph is positive. What should I get here? I should get a negative. So let's test. What's a good number between -2 and 3? What's an easy one? 1 would be easy. So let's test. 1 minus 3 is -2, so negative. 1 plus 2 is 3, so that's positive. When we multiply these together, we get a negative, and look, our graph is negative. Okay? Is the sign chart making a little bit of sense? Okay. And the last part is above the x-axis, we should get a positive value here. So if we pick a number bigger than 3, I'm going to pick 4 because that's easy. 4 minus 3 is 1, that's positive. 4 plus 2 is 6, that's positive, and I get positive. And so my sign chart matches my graph. And that's useful to confirm stuff like we just did. It's also useful if we were going to shade things like if we had to say, I'm going to write in a pen you can see, if f of x, if we change this problem and said f of x is greater than 0, I would have to say that's only true here, and here, and here. Because those are the 3 places that it's positive. So I could say if x is less than, oh, that doesn't work. I'd have to make 3 different little intervals there. I'd have to say between negative infinity and negative 4. Because this one's 0 and it doesn't say it's equal to 0. And then between negative 4 and negative 2. And then also if it's bigger than 3. So, and 3 to infinity. So there's 1, 2, 3 places that my graph is, whoa, bigger than 0. And then I didn't include this part or the piece where it's equal to 0. That was kind of obnoxious. But this sign chart lets us do this by positive and negative. Positive means it's bigger than 0. Negative means it's less than 0. So at some point, look back at this if we do this on Delta Math so you'll know what they're looking for. We'll probably throw another one in there to practice too. Times x plus 4 squared times x plus 7 cubed times x minus 3. Okay, no one wants to multiply this out. Not me, not you, no one. Okay? Because this is cubed, this is huge. This would be a really long polynomial. So instead, we're thankful that we know some rules. We can count up how many x's there are and figure out the end behavior. And now that we know about multiplicity, we can give it a good sketch. So first of all, tell me what the zeros are. So Kaylin, tell me what the zeros are. Okay, 3. Here. So instead of x plus 7, we'll say x equals negative 7. And then here, yep. And this last one, just 0. So this one throws a lot of people off. You set each piece equal to 0. So when you set this one equal to 0, like you're done. There's nothing to solve there. So 0. So we only have 4 different zeros. But if somebody was just evil and told us to multiply it out and we spent an hour doing it, we would have the degree of what? There's 1x here, so 1, 1. And then 2 here, that's 3. And then 3 more, that's 6. And then 1 more, that's 7. This is degree 7. So how about that? Counting it up, does that make sense? So I know some really important things. I know what it should look like on the ends, and I know the zeros, and we just talked about multiplicity. I could have given you something even more interesting, but here's the thing. If there's no exponent, this one is a 1, so it passes through. Can't even spell the bad through. Okay, through. This one is odd, and only the even ones bounce. So this one is odd, it goes through. This one is even, so it bounces, and this one is odd, so it goes through. So you try it. Give yourself a minute, write down all the zeros, sketch it, see what you come up with. See if you can understand what it means to do the ends, and then connect the dots with only one of them bouncing, okay? Okay, so let's check and see. Our end behavior is odd, so it's going to look like Saturday Night Fever. I don't have the same middle behavior. I'm going to have more wiggles in there probably. But this one ends up on this side and down on this side. And then it only bounces at negative 4 here. Okay, so I have that at, wait, Oh, this is positive 3. At positive 3, I only go through, so it really should be straighter than what I have. I'm going to add a little bit to mine to help you out. That's supposed to go through 3. At 0, it goes through, so through. At 4, negative 4, it bounces, so it comes down. Try not to make it pointy, so it kind of curves down to it and then comes back up. And then what happens at 7 is kind of interesting. Even though it goes through, it kind of does a extra flattening there because it has a high degree of the at negative 7. So the 3, it does go through, so that's absolutely correct. And if you draw it straight, that's fine. But what happens is when this degree is a little bit bigger, so a higher degree than just 1, it gets a little bit flat. So it like approaches that value and gets a little flat and then comes down. So that gives it that extra little wiggle that makes it to the 7th power. So did your graph look something like this? Your part down here may have come down lower. You may have done this. You may have gone higher. You still had to bounce here. You may have come higher and you probably went a little bit straighter. That's still fine, okay? We're not really talking about how high or low these go. We still recognize that there would be some sort of maximum on this side, right? 2 maximums, and then this would be some sort of minimum, but we'd have to do more calculations to figure that out. So this is just a sketch to give you a sketch. But we know a lot, and we graph really complicated thing quickly, okay? So I want to do one more sign chart so that you can try one of the inequalities for homework. And you know what? Actually, I think I'm going to go through the sign chart, but then I'm going to have you work on problems in class on Monday so that you can just work on them and ask questions if you have them during class. And I've kind of felt like this was a good weekend because it's not distance learning weekend to not give you homework. So I'm going to go through one more example, but there won't be homework. We'll look at this again on Monday and actually work some problems. Okay? Is that cool? Yes, I know it is. Okay, so let's look at this. If I have, so this is going to be my actual example is number 64. So when we get to these problems in class on Monday, you'll have an example that's like straight from the problem set because I'll probably give you odds to do. This says x plus 2 squared times x minus 1 greater than 0. Actually, I changed this problem. It's not 64 because I don't want to make it too easy. So it says solve the following polynomial inequalities. So greater than 0 tells you that you're looking for positive values. So this is what you're thinking. And so that should tell you you need to do a sign chart because you're only looking for where it's positive. And then wherever it's negative, you know that's not part of your answer. So in your sign chart, what I want you to do is make a list of these factors. So we did that vertically. And you keep the squared on there if it has a square. And then on the bottom, what you put are the zeros. And the reason for that is because a 0 means if it's equal to 0 that it's negative on one side and positive on the other. Maybe it bounces. Maybe it's positive, positive on either side of it. But zeros are the only place where it can change sign from positive to negative. So down here, I'm going to put this one's negative 2 and this one's 1. That's my right order. I do have to put them in the right order. Always saying small to big. So then we're going to plug in things. So before I go plug it in stuff, Javier, what number would you like to choose on this side, small side of 0? I mean negative 2. Okay, so negative 3, that would be what I chose. How about between negative 2 and 1? Negative 1, okay. And then bigger than 1? 2. Okay, so If we just say that in advance, then everybody can use the same numbers. We'll feel like we're doing the same thing. So in this chart, you can draw yourself a line here to just separate them out if you want, but I'm only considering -3 for this column, -3 plus 2, but squared. Actually, this one I could just fill out everything, can't I? If I'm going to square it, this one's positive, and this one's positive, and this one's positive. So that's easy. -3 minus 1, that's going to be -4, so negative. Now I'm going to plug in -1. -1 minus 1 is -2, so negative. 2 minus 1 is positive. So this, if I multiply positive times negative, my answer, so down here I'm going to write out what happens when I actually multiply them. This part would be negative. This one would be negative. This one will be positive, and I look back at my original question, and what is it looking for? Is it looking for it to be positive or looking for it to be negative? Positive. It says, where is the function, that means this part, bigger than 0? So this is what we need, positive, and we need to turn this into intervals. So this is all the numbers to infinity. This is the number in between -2 and 1. I need the interval from 1 to infinity, and that's my answer. That's this section. I cannot include 1 though, because at 1 it's a 0, and this doesn't say equal to 0. It says it must be greater than 0. So I draw that parenthesis there to not include 1. So the sign chart, does that make sense to you guys? Okay. I think I've gotten better at explaining that because I didn't do a good job a couple years ago, and sign charts confuse people. But it's just pluses and minuses. It just doesn't matter what number you plug in, and that does give people it doesn't feel as mathematical when it's not precise. But we don't care about what number it is, just that it's positive. Okay, so we're going to have some questions like that in the practice problems that we have for Monday. So we added multiplicity, graphing, and the sign charts for inequalities to our lesson. I want you to bring these good ideas on Monday, and we'll practice some problems together, okay? Okay, and that's it. Thanks, guys. Have a good weekend.